Perfect. All right. Thank you everyone for joining us today. And thank you to David Patterson from Latrobe Magnesium for coming along. I'll hand it over to David in a second. He's going to run through the company's most recent investor presentation. And then at the conclusion of that, there'll be an opportunity for Q&A. We've had a number of investors and interested parties send through some questions beforehand, which I've collated. If anyone has any questions throughout the presentation, please submit them via the Q&A section. There should be a little button at the bottom of your screen. And then at the end of the call, we'll have about 15-20 minutes to run through as many of them as we can. David, I'll hand it over to you.
Thanks, Alex. Welcome to everybody today, and thanks for giving us your time for LMG's first webinar section that's been conducted for shareholders, the community, and all our stakeholders. I would just like to ask all the participants to read the disclaimer on page 2 of this presentation, so you're aware of what we're going to talk about, if there's numbers, and just to advise everyone that this presentation is just a shortened version of the longer one that was lodged with the ASX on the 25th of August. We will be putting this up on our website. So I'll get now straight into the presentation. We'll talk about the investment highlights. Latrobe is one of the most advanced magnesium projects globally, even though I know a number of parties would think that we've been at it for quite some time. It tends to happen in the magnesium business. The only other person that's in construction at the moment is Alliance Magnesium, which is a private company in Canada, and they've taken probably just as long as we have. So we have all our approvals in place. We have started the EPCM. We have signed the EPCM agreement with Mincor, and we've started the engineering design works and some commissioning of our early works on site. We'll talk about that later in the program, in the presentation. Demonstration plan is basically has been structured to be at 3,000 tonnes per annum, which is really the smallest commercial plant that we can put together. $28 million in revenue, $4 million of EBITDA. So it is sustainable, and it's a plant that we can then modularize and expand very simply. And we're looking still to build that up to 40,000 tonnes per annum. And that would start within the first 12 months of the initial plan. Magnesium market still growing strong, had a little bit of a hiccup through COVID, but has come back since then. And the projections are still for another 1 million tonnes to come on stream by 2027. This doesn't really even include a lot of the tonnage that the Chinese have forecast that they'll be bringing in their 13-year plan. So if that in itself is 1 million tonnes, which we talk about later. The ECG credentials, I think most people know about Latrobe. We are 50% less than the Chinese in CO2 emissions. We'd like to get that down further, and we will be looking at renewables. We have had those initial discussions with the Gibson Climate Change Network, and we'll be looking to bring that in for any expansion of the current plant. Beauty about what we do is we just clean up all the waste material from the burning of the brown coal in the valley. So we're really a recycling industry, and we do not have, if you like, hazardous toxic waste from our process. We've got decades worth, as we've said earlier, decades worth of supply. Your lawn itself would supply over 30,000 tonnes per annum for the next 20 years. We would hope that we would also be able to speak to the government over that period of time, look at Hazelwood, bringing in Hazelwood and getting rid of their ash dam. We haven't been able to organise that with Engie today. And we have other product we could bring into the valley, which is not toxic and which could feed a bigger plant. So we could make that sustainable. LMG board, a lot of you have met. We have expanded our team with the employment of 5 very accredited individuals. in the valley to take us through both this construction phase and the operation stage. And most of those parties have been responsible for developing projects up to $1 billion. So very much can handle the process as a project of this size. The next slide, page 4, really shows our expansion capabilities into the future. We talk about, as we said, stage 1, 3,000 tonnes. There's an option also to go to 10,000 tonnes, depending upon the results of our initial plan. So we could go to that very simply and very quickly, and then our 40,000 tonnes per annum plant, which we've talked about, and even increasing further with our ferronickel size up to over 100,000 tonnes. So plenty of expansion opportunities for us in Australia and overseas. It's effectively all dependent upon our performance of our initial demonstration plant in the valley at 3,000 tonnes. There is, as you can see, some reduction in CO2 emissions on this slide. That's the bottom. I'll direct you to the bottom lines of each plant. And whilst we're looking at 10.2 tonnes, China emit 21 tonnes, so you can see we're under that 50% mark. The 3,000 tonnes per annum, that means the 10 tonnes will be emitting 30,000 tonnes of CO2 into the air, not millions, as per the power stations do. And also we'll be looking to make that a carbon neutral situation by looking at CO2 offset agreements. The 10.2 and 10,000 tonnes is predicated on the same process working, but hopefully we'll be able to bring in vertical retorts, and that's one of the main reasons for the 10,000 tonnes dropping, the emissions in the 10,000 tonnes dropping to the 40,000 tonnes, nearly halving. And the reason for that is the efficiencies of vertical retorts in heat utilisation. So we would hope that we are doing work with CSIRO on that element at the moment as we go through our building of the first stage of initial plant, and we would hope that we'll be able to bring that into any further development. Stage 5 talks about our clear strategy to become a globally significant producer. You know, it really is our strategy to also leverage our unique technology. The HydroMet technology is not just, as it was in the past, an alkalized technology, which was used to look at treating Hazelwood fly ash and RWE power fly ash. We had to develop a new acid technology to treat the Yallourn fly ash, and that's because of the harder mineralogy. But the beauty about that is it also was able to treat the ferronickel slag, which is a very hard material like the Yallourn situation. So in all of our projects that we look at, even offshore, we look to put in a royalty to those projects so we can recover a large amount of our costs that we spent already on developing those technologies. The construction of, as it says here, we construct our 3,000 tonne plant and then looking to increase our, and the beauty about the construction is that our 3,000 tonne plant has been approved as a research and development activity, and therefore in round figures we get 50% of all capital costs back. So the $4 million, why it may not seem great on some $60 to $65 million worth of capex, when you start reducing that by half and then looking at some government grants, hopefully, then your EBITDA should be in the order of about 15% of the equity invested. So a solid return, not a great return, but that of course goes up when we look at those increased productions and we get economies of scale. The advantage of our ECG credentials being one of the lowest CO2 level producers in the world is and we can reduce that hopefully, as I mentioned earlier, with expansion with renewables. It's very important for our end users because most of the automobile car manufacturers and who have agreed to go to electric vehicle cars, and they're talking about zero emissions in 2030s to 2050s, depending on the OEM. So very important for them to get magnesium with reduced CO2 emissions. For example, Tata in the UK have already come out and said they won't buy China Mag because of the emissions in China Mag of 21 tonnes CO2 per tonne of mag. So it improves our market as well as being a responsible citizen. Why do we get it produced at a lower cost, or we can compete with the Chinese? Predominantly that's because of our other products that we make. It represents about 30% of our revenue, and therefore it's because of the feedstock that we have in the fly ash and all the ferronickel slag, which is not available in the dolomite, which is used to make magnesium in China. So they can't make those products. We make them, and we can get a 30% effectively reduction in costs because of the profits that we can make from those products. Diversified magnesium supply chain, very important. As I mentioned earlier, the OEMs have converted to, which we'll talk about in the next slide, in the market analysis on magnesium, but they have converted. They are all converting. They are all going to electric vehicles. And an interesting article I was reading actually yesterday was on the EU magnesium price. It's the highest it's been at the moment since 2006, 2008. And that's because, once again, China, a bit like through the rare earths situation back in the global financial crisis, the rare earths, China are even not delivering at this price because they have they have yearly contracts, but the price has doubled in the last year from 2,400 to 2,600 to, at the moment, 4,800 US. I'm talking a ton, and that's China Mag. So the OEMs and their suppliers, which are usually the aluminium sheet people, are always looking for long-term contracts from Western suppliers. If we talk about now go into the mag market, then it is still set to double. It has picked up and recovered from its probably 10 to 15% drop through COVID, the initial phases of COVID, but with the steel business, as you would have heard, the iron ore business, it has picked up dramatically. Of course, we haven't got in here the current news, but the current news, which you would have seen in previous slides, if you're a shareholder, aluminium sheet and die casting in the mag business is now up to 37%. So you can see that is the number one use, and that's because of the aluminium sheet used in OEM in cars. It's only basically happened since 2016 when Ford, Ranger, and other major users, major car manufacturers, OEM providers, effectively started picking up the use of aluminium sheet, retooling all their production units, manufacturing units, to also take that into consideration. The second most element, aluminium cans, also around 37%. So you can see that's 74%. That's up a bit, and mainly because of the green push to actually use less plastics, and therefore cans have moved up a little from traditionally 33 up another 10% to 37. Steel desulfurization, 13%, has gone down with the others increasing. Titanium sponge, also around that 7%, and then other uses 6%. So you can see that major shift to aluminium sheet. We're getting basically pulled along by the aluminium guys and their use of sheet. Sheet requires, depending on the part, 1 to 6% mag alloy, and therefore you can see why that's just pulling us along. We've talked about most of these elements in the points, and I won't just reiterate, but I suppose it's, as I mentioned earlier, the 1 million tonnes. China alone, as it says, is in the 13-year plan, is 1 million tonnes, and you can see how the aluminium sheet has moved that usage. So you can see on that chart on the side, production is still moving up, and it will be this year. So mag alloys, there's other elements. Just quickly, there's other elements. We've got two of them here on the next slide, which is we're talking about those, the sheet in cars, and we're talking about the level of CO2 emission. There is hydrogen storage discussions, and that's mainly the liquid magnesium, liquid metal batteries, which can use magnesium, and that's for large battery storage and for grid storage. It hasn't been basically developed for cars at this point in time, but the Japanese are doing a lot of research into that. Other things like 5G base stations, the wind turbines are now using mag because it's anything lighter, stronger, and can go further, as well as lighter, stronger, other uses. I think we've been through the electric cars is interesting because the thing about a lithium battery, they've proven that lightweighting a car is more efficient than the use of lithium batteries, and that's because a lithium battery is roughly 25% of the weight of a car, each about 500 kilograms, and to increase their efficiency, and that's longer life, further distance, they need to lightweight the car to take into effect the lithium. The push for magnesium ion batteries and other sorts of batteries is really when you start comparing lithium, it's to magnesium. Magnesium is about a third of the cost, and the reason for that is it's the 7th most abundant mineral in the world, or dolomite is. So there's a push to look at reducing costs in batteries as well as their weight. And the other thing about magnesium, it's got better conductivity. It's got about twice the storage capacity. So there's pressure all the time on magnesium globally to be environmentally more friendly, and that's the challenge that we still have. And that's why we're looking to decarbonise the process. At the moment, our CO2 emissions only come from the gas, and we'd love, as we said earlier, to be able to move that to renewables, and that's what we'll be looking for in the future. So looking for renewables projects and offtake agreements so we can reduce the CO2 reliance on gas and therefore our CO2 emissions. Timelines for the construction, where, as we've said here, we're securing capital by the end of September. That's moved out a quarter, principally because of COVID and some of the test work that we have to do and the sample preparation we have to do to effectively bring in our two cornerstone investors, and that will move out in the next quarter. That does not affect our timing of what we're doing on site, because we have Mincor doing the detailed engineering and design of the plant, and they are also starting to put together the packages. So we have tendered 4 packages for the site cleanup and early works, and I can say that, pleased to say that that's all gone to local contractors in the valley, and we're hopeful that trend will continue. So we're looking to start construction in December, start construction on site really January next year, and that's once we have all these major packages tendered and starting to get delivery. In broad pictures, the longest lead time item is the spray roaster. That's an 8 to 9 month cycle to get that ready and then get it out here because it will be produced overseas. And that's the major long lead time item, as I mentioned. And with that 8 months starting in January, we should be able to then start commissioning the plant by December next year. So production will start soon thereafter. And once we've proven that works, we'll start to look at the expansion options around that 3,000 tonnes. So the last slide really is just a summary of what we've talked about in this presentation. The 3,000 tonnes per annum, basically at producing 28 million. This pricing that we have in here at 28 million and 4.5 is not at the current double price that's out there today. We do not think that's sustainable, but that's one of the things that's come out of China, principally because of higher input costs and also because of a number of places are getting closed down because of their CO2 emissions. So that is actually happening in China, which is good for the world on their CO2 emissions. And I can say that is the effects of that has been actually reflected in the marketplace. We talked earlier about our proprietary technology and the beauty about we're the only unique. It's a unique technology both in an acid and alkali process, and that enables us to be cost competitive. It enables us to treat, as we've said before, ferronickel slag. A ferronickel slag producer approached us because they have not been able to solve their problems and treat that material and also therefore recycle it. And that's how we got as much as our acid process into that business. So it gives us a business outside brown coal as well. Lower emissions to date, hopefully we'll get those reduced even further with further use of renewables. Magnesium market, we've talked about the growth in the magnesium market is there anyway because of the the aluminium sheets in the OEMs to lightweight the vehicles, and even more so with the electric vehicles. Diversification of supply away from China, 85%, I would say most parties, and we've had a lot of inquiries from the smaller users of mag because they're very worried about where the price has gone over the last 6 months. So our push is, of course, as Australia also imports 100% of its magnesium uses to supply some of those local players, critical raw material worldwide. And that critical raw material is in Australia, Japan, USA, and EU. So that allows us to get some funding for these larger projects that we want to take on stream. I think I'll hand back. Thanks for listening.
Perfect. Thanks, David. And for anyone that jumped into that a few minutes after we started, this presentation is being recorded and we'll distribute the recording to all the attendees, but it'll also be available on Latrobe Magnesium's website for anyone that wants to have another look. We've had quite a few questions come through during the presentation and a few before. I'm not sure if we're going to be able to get to all of them, but I'll start working through them and we'll see how many we can get through in the next 20 minutes or so. So the first one for you, David, someone has asked if the magnesium market has increased globally due to the proliferation of electric vehicles, and if it is in fact the case that magnesium can be used to increase efficiency in the batteries of electric vehicles, and then just commenting on some of the media commentary that's surrounded this issue and how it might affect Latrobe.
So magnesium is increasing, the usage is increasing as that chart showed, and that's just normally in ICE vehicles. The movement to electric vehicles is underway, but it hasn't really been taken up. The only place it has been taken up actually is in China, where you've seen very big increases in the use of electric vehicles. The rest of the world is taking a time to catch up. On the use of magnesium ion batteries, which they're looking to take on, it's really still in the research and development stage. And that's when I mentioned taking on the lithium batteries for cars. In the liquid metal battery area, that in the States, it's already a big thing. You've had people like Mr. Gates investing 120 million in Ambri, which is a company that's formed out of Cambridge University, and they've already instigated big storage battery capacity in the US. Lithium has problems when you get to big storage capacity. It has a tendency to fire up. There's been 20 to 30 odd recorded cases in the States. That's why they're leading the charge. I think there's been one in Victoria.
That was a couple of weeks ago in Geelong, wasn't it?
Oh yeah, that's what I believe. And so there is a big push for that. And as I said, a lot of money is going into into that sector. So that's imminent. It has been commercialised, and they're going to commercialise it in a bigger way.
Another question that's come through, wondering if there have been any plans to establish a plant in Malaysia, given that there's an abundant supply of material available there for producing magnesium.
When we talk about international expansion, that has been looked at, as well as Saudi, as well as, of course, Germany, that a lot of people know about RWE Power. So all of those things will be looked at, but the focus at the moment is to get the 3,000 tonne per annum demonstration plant up, working, proving the technology, so then we can move on to bigger things. There is, as we've got in the slide, we haven't put in RWE, we haven't put in a number of other projects where we've been approached. We actually have to bring home the 3,000 tonne plant, take one step at a time, and then expand that out for the valley, and also look at our other expansion opportunities.
Yeah, I mean, this probably linked. There's another question here about the plans for expansion, and that probably answers the question about international expansion. But did you want to touch on, and it might be the same answer, any plans to expand locally as well?
No, I mean, the plans locally are still centered on the valley. We see that there's, as I mentioned through the presentation, we have your lawn that has an existing ash landfill with quite a bit of supply in it. We have Hazelwood HAP 4 dam, which is 5 million tonnes, which is, once we get up, I hope that they will see the light and rejoin our efforts so we can actually get rid of that HAP dam, so it doesn't form any problem, or it doesn't create any problems in the future. And as I said, we can also bring some inert product in from outside the valley if we need to supplement that, to maintain that 40,000 tonne plant.
Yeah, perfect. And back to the demonstration plant, someone has asked if you could provide an overview of the funding sources for this $65 million capex that's required up front.
Okay. Basically, as I mentioned, we have in the presentation there, we have a advanced ruling for our research and development. The plan as being a research and development eligible activity. And when you take into consideration capital costs plus operating costs for the period, we effectively get 50% of the capital costs back. So if you're talking 65 million, in round figures, 32 million. And we were looking also at then raising $20 million in equity and government grant, and $15 million in project finance for the expansion into that. So $20 million, most of that is getting raised from the cornerstone investors that we're bringing into the party. And then we've got an application before the state government for $4 million.
Okay, perfect. I might try, for this next question, I might try to group a few together. There have been a couple of questions about, when it comes to the fly ash, what is Latrobe's plan for managing the potential emissions and byproducts? And just, do you want to make a general comment about how that's going to be treated and used in the process?
Yeah. So the fly ash, when we're managing the fly ash, it's all about making sure fly ash does not escape. So the fly ash we get from your lawn will have about 17 to 20% water in it. So then we can transport it safely without it moving from the trucks, and we'll have it covered trucks. The small plant only needs 4 truck movements a day. So it's not a lot, but it's still got to be managed. Then we'll go into silos, and all the facilities except for the spray roaster, which is an enclosed facility, are done within the premises. So that's another part of making sure that it doesn't escape. And we do have a number of parts which we have recognised in the area that make sure that we'll have dust houses, so we can collect that dust in basically a vacuum, so it's clean. And our employees will make sure that they go to work as happy and as healthy as they when they leave. And they'll be in those particular positions where we have recognised in our engineering studies that the dust will be generated. They'll be put into PPEs and also, proper materials. So there is no problem with them getting silicosis or something of that nature down the track. Protecting our employees is number one in our objective in LMG's corporate objectives.
A follow-on to that might be, and this has come through from someone else, talking about the recycling of the waste that you have planned.
Yeah, the beauty about, as I mentioned, 30% of our revenue comes from the recycling of the waste. The products we make from the waste. So we're recycling all our waste. There are no, except for the CO2 emissions, no toxic emissions coming out of our process. The products that we're making are mainly cement, and that's a CO2 free cement. That's the biggest, if you like, the second most valuable product. And then we're making because of the high iron oxide content in your lawn fly ash, we are making a very high grade hematite, which can go into the steel business. We're making a calcium carbonate or an ag line. Calcium chloride, I should say, which is an ag line. And that is a very good ag line based on the chemical analysis, and we'll be sending that around to local use in the agricultural business. And then we're also making a char and silica, which chars the young bird. We make a good char, and we're looking to a local manufacturer of briquettes to take that char.
Another question that's come through. So asking if you have been, given that you've been fielding inquiries from end users, has there been any progress to securing binding offtake agreements?
Yes, I mean, we always have had offtake agreements. We have a distributor in the US that is guaranteed to take 40% of our product. And we also have a Japanese distributor who is taking our product. So the 3,000 tonne is definitely sold a number of times over, and it's very easy to get 10,000 tonnes, if not the 40,000 tonnes. Selling magnesium and definitely low CO2 is not an issue. What we have said before in our presentations, but we didn't go through today, was, you only have China, as we mentioned earlier, supply diversification. They make, in round figures, 900,000 tonnes. Around 400 of that gets exported every year, and that goes to Japan. No producers. Goes to North America, one producer at the moment, with one to be up. But they look at importing 150,000 tonnes. No producer in the EU, also 160,000 tonnes. So it's not a problem to sell mag, and especially once you're producing a low CO2 emitted mag, which is everyone's looking for. People like the EU, for example, will be putting tariffs on people to CO2 emissions. They've already come to that situation. So, it's if we are not a low emitter, you will have issues in the EU, for example.
Yeah, definitely. That actually probably is a good segue to one of the other questions. Someone's asked, given that Tesla are producing electric cars with large aluminium die-cast assemblies, the aluminium there is a custom alloy, highly likely to include magnesium. Tesla, like many others, have a very strong focus on suppliers who have CO2 mitigation and environmental controls in place, so possibly a good fit. Have you contacted them, is the question.
No, we haven't, because we haven't contacted the OEMs. We actually have, with our distributor, manufactures parts for Tesla. That's part of his business. Half of his business is he runs 9 plants in the US, and the other half is his trading business. So he's the best to understand. His main business is in aluminium, but he uses mag, as you've just mentioned, and he will be his only mag supplier. So we basically use that scenario in our distribution chain, in sourcing that offtake agreement. And the other thing I've been told also is Tesla are very keen to buy carbon credits generated from magnesium, and we've even told that through our carbon broker, and they're very keen to do that, and we'll be talking to them about that in the future.
Yeah, brilliant. Might go through two more questions, just conscious of time. First one, asking about the construction timeline and wondering how likely is it that it will commence in January 2022? And if not, what are the other factors that might delay things?
At the moment, it's just getting samples, as I mentioned before, that we were delayed from COVID, and that's a real delay because, as people may or may not know, we do all our hydromet testing in WA with ALS and Bureau Veritas. So we have to actually ship fly ash to Perth, and then we have to get it back, and then we do our smelter work at CSIRO. Now with COVID, that has been a problem, getting product in and out of WA, as well as having the people at labs because of lockdowns. Similarly, even in Victoria with CSIRO, they have not been able to have an analyst in their labs. We've been able to get the, if you like, the doers in the well, it's a big lab that we use over in CSIRO, so I hardly call it a lab, but we get the doers that process the mag oxide into and do the smelting work at CSIRO, but we haven't been able to get the guys in the labs. So until recently, so I can say that we have produced those samples, and we're on the process of producing those samples. We've done the first stage in WA, and they have got to CSIRO, and they are getting processed at CSIRO, and we do have the technical capabilities to do the lab analysis at CSIRO, approved as a essential worker. So that's only been recently. So that's why there's been delays in samples and delays with our cornerstone investors who just want to review the work and want some physical samples to review, which is very understandable.
And maybe one follow-up from that, you mentioned the hydromet process, which we haven't, there's mentioned in passing on the slides, but do you want to just, as a closing statement, talk a little bit more about the hydromet process, why it's, how and why it's unique compared to others?
Initially we developed as I said, for Hazelwood back in, up until 2016, 2017, the alkali process. Alkali process is cheaper because it doesn't use, and it's less CO2 emittive because it doesn't use high energy, and the capex and operating costs are therefore cheaper. What we do in the acid process, we've got a spray roaster, which is about 30% of our capital costs, and the spray roaster effectively is just that. It's a 20-meter high vessel, and it sprays basically the mag chloride down onto a roasting bed. And what happens is the chlorine gets released and then gets recirculated, and the mag oxide is made. So in one process, that process requires heat, requires energy, and therefore, that bit of kit is very much more expensive than just having a simple calciner. So that's the one differential, but the acid process is able to treat very hard material. Your lawn is very hard material, the fly ash. And similarly with the ferronickel slag. So we were able to use that same process for ferronickel slag, which they haven't been able to do in that whole industry. And there's probably 50 of those plants around the world, and fairly close to us because they're Indonesia. They're all laterite nickel deposits around Indonesia, Philippines, Malaysia, not so much Malaysia, but Philippines, New Caledonia, and then through the Jamaicas. So,
and I suppose importantly, the process that you're using, or the combination of processes, is unique to you.
Alkali is unique, and so is our acid. We've patented the alkali process wellbore, and we're in the process of looking at patenting the acid process, but there's no one in that space. We know that from our patenting work that's done by Alan Allens. So, yeah.
All right. Well, we've got a few more questions, but I'm conscious of time. We've just ticked over 40 minutes. So what I might do, as I said, this webinar is being recorded. Contact details for Latrobe are readily available on their website. We'll also email them around to all the participants for those that weren't able to have their questions answered. But otherwise, thank you, David, for running us through the presentation and answering these questions. And as I said,
what might be better for the ones we haven't answered, we could also just do that individually and send a response back to them, seeing we've got the email addresses of those parties. So more than happy to do that, so we can answer everyone's questions.
Perfect. All right. Thank you, David. I might stop the recording here. And as I said, we'll send it around once we're done.
Okay. Thanks, Alex.
Thanks,
everyone, for attending.